Hello everyone. I know audio has been a bit of an issue. Can you hear me well in the back and in the middle? All right. If I start to tone down the volume, wave your arms. I'll know that it means I should speak up. So let me just get to the next slide here. I'm here today and I'll talk a little bit about the history and what led us to WebRTC and where it is today. So I'll ramble on a little bit about the past, take a look at where we are now, and give you a quick update over what's going to happen over the next few months. I'll be here all day. I've got two partners in crime with me here today, Jan Linden, Jan over there, and Vikas. I don't know if you can see Vikas anywhere. If he's not here, maybe he's in the back over there. Grab him later if you have any questions. We're more than happy to answer. So I'd like to start off with looking back at how I got involved in the wonderful world of RTC. I guess I first got connected with RTC back in 1995. I was a student at a university in Montreal, Canada, and I worked at Ericsson to pay for my studies. In one summer, I think I logged something like 1.3 million photocopies. I did expense reports for everyone, and at nighttime, I got to do billing runs. Now, a billing run in the telco world at Ericsson was a room full of phones where we just took one phone, called another one, put one on hold, and then made sure that the billing was okay for that particular call. And that was the last step in the testing of the software. And back then, I got the opportunity to meet a bunch of Swedes from, from northern Sweden that were working as contractors in Montreal. And that's how I got convinced to go and become an exchange student in Sweden. What I saw when I arrived in Sweden blew my mind. This was 1995. Northern Sweden, super sparsely populated area of the world, had all the villages and small towns hooked up with a 50 megabit fiber backbone. This was amazing. In Montreal, I was playing with Mosaic, Windsock, and Trumpet, and on a 28.8 modem, and thinking I was a cool guy. And here I come to Sweden, and I see software like this. What you see here were open source tools, part of the MBone project, the multicast backbone. And they allowed groups of people to interact with audio and video. And what you see here is VAT, the voice audio tool, and VIC, the video tool. And there was another SDP session management tool, which I don't really remember the name. But I started working with a research group at the university, and we started to build prototypes around these tools and around this open source software. And we started a research group at the university around how we could improve engineers' collaborative work over distance. The tools became popular. They became too popular for the university to handle. There were requests on support, updates, feature requests, bugs that needed to be fixed. And as a research unit, we couldn't pull that off. So we started a little company. We call that company Marratech. And we built tools to allow large groups of people to interact with audio and video over the internet. This company was founded in 1998. It took us about 6-7 months to get the funding, so let's say June 1998. That was way the hell too early. We had the ideas, we had the use cases, we had a large group of people that wanted to see this happen, and it was a very big challenge. One thing that we had was a great network stack. We had a network stack that supported both multicast and unicast and provided end-to-end encryption for these large conferences. And that was a key asset we had. But this is where, as an entrepreneur, we hit our first RTC wall. And this was a very tough lesson. We tried to tackle the signal processing challenge that laid before us, but we did not succeed. We wanted to provide our users with an immersive audio and video experience, something that just worked. And it was too hard. We did not have the signal processing chops to pull it off. Remember, we were a 10-person company, and Even if we put half of our resources on trying to solve this, we just couldn't pull it off. So we resorted to licensing technology. We licensed an audio stack that provided echo cancellation, noise suppression. We licensed a video stack that was one of the first H.264 video stacks out there. We had to license patents, and for a small company in Sweden, going through those hoops was quite a challenge. And then we had to take these two stacks that came from two separate companies and make them work together very well over our networking stack. And we had to do this so that it worked on Linux, Mac, Windows, and back then Solaris. Heck of a challenge. So doing all of this was pretty exhausting. Updating software in the background and doing so in a way that didn't kill ongoing calls. Keeping up with OS updates, keeping up with Java updates. We had the brilliant idea of making all of this on top of Java on the client. Write once, run anywhere is much more adapted to JavaScript than it is to Java, let me tell you. And back then, if you remember Mac OS X, it was iterating very quickly, and so catching up with Apple all the time was tricky. But we had a measure of success. Apple was our exclusive reseller in North America. We had some of the most prestigious universities and institutes in the world running our software. And so looking back at it, I have to remind myself that we had a lot of users. We had a lot of happy users. Our software was used in the way that it was meant to be used, which means collaborative work. But we were too early, and solving all these issues was exhausting. In 2007, after a year of working as a consultant deploying our solution at Google, we were acquired. Great. So 10 years of work, and we had a wonderful exit, and I was hired as a product manager at Google. And I hooked up with a guy called Justin Uberti, who was based out of Kirkland, and we were both tasked in bringing a video chat experience to Google users. We chose Gmail as our vehicle for this. And so with Marratech, with about 10 years of work, I guess you could say we had about 300, 400,000 unique users, all of them were running off of paid installations. When we launched Gmail Video Chat, we got that after a few minutes. This was exhilarating. I had never deployed software at that scale, and it was an amazing thrill. But we had to solve the same kind of challenges that I had to solve and that we had to solve 10 years ago. But we had to solve them on a much larger, much scarier scale. Okay, we weren't just updating software for hundreds of thousands of users, we were updating software for millions and millions and millions of users. We did not just have to test on Mac, Windows, and Linux. We had to test on Mac, Windows, Linux, Internet Explorer, Safari, Firefox, and Chrome on all those platforms when applicable. We had to tackle the challenges of integrating a separate audio stack and a separate video stack together on top of a network stack that we had built. We had to offer seamless plugin updates. We had to offer a super easy install experience for this plugin, not an easy thing. You'd be surprised at how hard it is for people to download a file and install it. And security. The world of plugin security is a very scary world, and I can tell you that you need to invest a lot of time and resources to cover all those browsers, all those operating systems, and make sure you're not leaving anything wide open. So here we are in 2009. I've been able to be part of an amazing launch, which I consider myself lucky to be able to be a part of. It's a success. We look back, and Hangouts had been designed, and Hangouts was deployed at Google in 2009, and we were starting to use it internally, replacing our traditional video conferencing equipment. It's a key secret to Google's success is the amount of conferencing going on. In terms of minutes, I think we're up to something like 20,000 meetings a day on our Hangout system internally at Google. And I don't know how many employees we are, somewhere around 30,000, I guess. So that just gives you an idea of how much people communicate internally using these kinds of tools. So Hangouts was being built, being deployed, used internally. We knew it was going to be a hit. But looking at the market in general in 2009, there was kind of stagnation. You know, state of the art in VoIP was still, you know, making a standard phone call. There was not much video going on. And I just had a feeling that things were stagnating very quickly. That's when we got a call. And I really mean a call. My phone rang. It was a Chrome team calling, and a couple of the leads on Chrome calling me. And the lead engineers for Chrome, which had just launched a year earlier, had done a gap analysis on the differences between the web platform and what you could get from a native desktop experience. And if you saw the list back then, there were things like better graphics, which were being tackled by WebGL, better audio, which was being tackled by WebAudio, offline, geolocation, all those things had plans for. So there were concrete plans either internally or out there in the web community for addressing these gaps. The one big gap was human communication. The ability to use my voice and have it heard by someone else on the other end using the web. Nothing was happening in there. It was still all dependent on plugins and on Flash. So we decided to put things in motion. Myself and a couple of others at Google, we decided to look at how to get this rolling as quickly as possible. Do we hire a team of signal processing experts? Do we go to the open source community and try to leverage some of the great work going on there? In the end, we decided to acquire a company. The acquisition was done in mid-2010, or the intent to acquire was announced. And it was a great ride. I must say that acquiring a company that's listed in Norway, that has employees in the US and in Sweden was quite a challenge. Nothing for the faint of heart, but got it done and got to work with an amazing team of people at GIPS, truly experts in their field. So we're getting there. We've got the components. That whole acquisition process, you know, just a small, tiny bit of starting this effort. Then we needed to engage the community. And we did that very early on. We started off with an informal lunch in Maastricht, where we invited people from Cisco. I think Colin was here. Are you here, Colin? There you go. He was there. He had lunch. And folks from Ericsson were there. Folks from Skype were there. And a couple of others from the IETF community that really knew how to drive standards were there. And so after that lunch, we decided to convey at Google. And here you have one of the examples of one of the disagreements I had with Harold. Harold wanted to call this effort RTC Web. I wanted to call it WebRTC. We did the most sensible thing. We did both. So at the IETF, it's called WebRTC, and at the W3, at the IETF, it's called RTC Web. At the W3C, it's called WebRTC. We had a full day of meetings at Google with a larger group of people. That's where we launched the intent to form 2 work groups at the IETF and W3C, and that's how the whole standards thing got started. And we decided to use Chrome as a vehicle to quickly iterate on the APIs and quickly give feedback to these work groups on what was working and what was not working, which is why in the early days of this effort, things were breaking a lot and things were changing a lot. In 2011, we open sourced a significant amount of code that allowed for real-time communication. This is an audio stack, a video stack, all the signal processing components required. And I remember this post very well. It was the first time we introduced WebRTC formally. It's the first time we introduced our intent to bring real-time communications to the web. I remember this post very well because I was working with Jan, who was in California. We were getting the approvals from the lawyers and the PR people, and I was in the delivery room with my third child almost being born, I pressed on post. 20 minutes later, my daughter Ella was born. Quite an intense day. Once we had the components out, we started in the public space integrating these into Chrome. And we started off and we iterated very quickly. We started off with Getusermedia, the ability to give something else than access to keyboard or mouse events or even file system to the web browser. Getusermedia today, you can plug in an electric guitar and get musical instruments going through Getusermedia. Getusermedia is also used as a basis for the web speech API in Chrome. So all these things have interesting synergies. We then added the first WebRTC peer connection APIs into Chrome and iterated on that. And all these were done doing canary, dev, beta, and then going to stable at a pretty fast pace. In February 2013, we hit a huge milestone. It was the first time that Chrome and Firefox could talk to each other. This was a testament to both teams, and there were small groups on the Mozilla side and small groups on the Chrome side that worked really closely together to get this done. A couple of them sat in a room for several weeks and just hashed everything out. So a testament to those people, but also a testament to the standards community, because if you have a very vague standard, the interpretations of these standards will be so diverging that something like this would be impossible. And this blog post is still on the top 10 blog posts of all time for Hacker News, which is, it got tremendous attention. But it wasn't just for show. It's a real commitment. Today, we have, on the Chrome infrastructure side, we have test bots that bring up both Firefox and Chrome in virtual machines and place several thousand calls a day on every line of code that's going in, on every new big changelet that's going in, to make sure that the compatibility isn't broken. And so it's something we're very committed to. And this testing and the fact that there's been very little breakage in this interoperability, it's a testament to all that. So now we're almost 80% there. Last summer, we introduced Chrome for Android. We don't just port all this software to ARM, but we bring this software to ARM, we optimize it, and we try to take advantage of the opportunities that are presented to us by the mobile environment. So we've been busy hooking up hardware to Chrome, and in many cases we had to make deep changes into the actual Android operating system to have access to this hardware. So for instance, hardware echo cancelers perform using less resources than software echo cancelers. So we try to use those as much as possible. Hardware video encoders and decoders for VP8 that are available on both Chrome OS and on most of the new Samsung phones, the S4, the S5, the LG phones, trying to make sure that we use those decoders when possible and those encoders to save significant CPU resources. So all these are things that have rolled out or that are rolling out shortly. Most recently, we integrated a new version of the audio codec called Opus 1.1. And the main benefit of this codec is that on ARM, it saves about 40% in CPU resources just for doing encoding and decoding of audio. So again, as soon as that was Opus 1.1 was finalized, we got straight to work to integrating it into Chrome for Android. We've got more VP8 hardware encoder, decoder acceleration support coming out shortly, and we're also working on video denoising for mobile, as cameras on mobile are pretty noisy. So we're 80% there. And then we get to the last 20%, or as I like to call it, the new 80%. We felt we had a pretty stable platform. The APIs hadn't changed for a lot. Our integration tests were up and running. We saw some early, many of you in this room, some early adopters reporting success. We asked for feedback, and we got a lot of feedback. We got a lot of feedback on what we should implement next, on what we should fix, on where we should bring our roadmap. And so this is where we got to work and spent an intensive year since last summer. We've added things like screencasting. We've added things like SCTP, allowing reliable, semi-reliable, or best effort communications for peer-to-peer between browsers. We added IPv6. We added CPU adaptation for when resources are low on your machine, so we can lower frame rates, lower bandwidth rates to try to save the communication. We added stats. We added stereo support, proxy support, turn support, a bunch of things. Read the release notes. In the coming weeks, we've got a new version of Chrome coming out, version 36, and a little bit after that, 6 weeks after that, we've got Chrome 37 coming out. And in those builds, you will see maybe a year's worth of work around bandwidth implementation, bandwidth estimation being implemented and deployed. And so we'll be a lot better at guessing what kind of capacity your network link has to the other end without destroying or hurting the call. And it's a very tricky thing to do. And the benefits from that is you'll see much better performance on Chrome calls using Wi-Fi. You'll see much faster screencasting, and you'll see that HD resolution you can use HD resolution a lot more often, and when you are at HD, you will be able to stay at HD for much longer periods of time. You're going to see much faster connect times. We've worked on streamlining a lot of what's going on in Chrome when you connect a call. Currently, we have a sample app called apprtc.appspot.com, completely open source. It's our test bed. We see connect times of just under 1 second for 2 endpoints to connect. We're going to reduce that by more than half. We're starting to see connect times of between 350 and 400 milliseconds, and we want to go even under that. That feeling of a call connecting immediately is really important to the experience. Quick connect times are super critical. I remember the first time I used Spotify, and I found the song, pressed play, and it just started in 2000. This was in 2006. I want the same experience for WebRTC, and with connect times of around 300 milliseconds, we're starting to get there. You're going to be able to choose devices directly from JavaScript in the upcoming versions. You're going to see forward error correction being implemented for audio, and you're going to see a long list of ICE and SCTP fixes being deployed. Lastly, one thing you won't see is paying technical debt. With a platform like this, an open source platform like this, with many external contributors, both inside and outside of Google, the code can get complex very quickly. And we've done a big effort on trying to clean out old code, remove old APIs, refactor current APIs, and also get the interaction with Chrome to be much, much more tighter. So a lot of the components might move into Chrome, and the threading will be optimized. And so it'll be easier for people here that are developers, and if you're not a developer, you'll see a much more responsive Chrome when doing WebRTC. So for parents out there, you know that once a child starts to walk, the game changes forever. That's when you lose any sense of security or confidence in life. And the other thing that happens once a child starts to walk, the first thing it does is it starts to run. And I feel that WebRTC now is running, and even I have trouble catching up with it. We're seeing things like The Economist talking about a web API in their magazine, something I don't think has ever happened. We're seeing Super Bowl announcements around thousands and thousands of pizzas being delivered thanks to call centers powered by this API. We're seeing Amazon integrate this in their Kindle experience for support. We're seeing Chromecast, a $35 HDMI dongle used to easily deliver content to your television, built upon the WebRTC stack. I would have never predicted that. We're seeing new ways of communicating, like Snapchat, something something, it's a completely new way of communicating for a completely new generation. And they're getting into the WebRTC game. We're seeing clouds being announced. We've had a couple of them. TalkBox, we're seeing Lifesize now announcing a big WebRTC cloud announcement. And America's favorite company is deploying a set-top box built on top of WebRTC. These are just a couple of the examples I looked at when I did a Google News search for WebRTC. But where it's really making an impact is in places where it surprises you and where you don't expect it to be. So, for example, and this is my experience, so for example, an HDMI dongle, who would have thought? Robots running around, golf ball kiosks, another thing coming here I would have never expected. Experiences such as pipe.com, a Facebook app you install that brings you like a Super Mario pipe where you can just drop files in and the files get piped to all your friends, built on top of data channels. Anti-censorship proxies, augmented reality experiences. And one of my favorite experiences happened a few weeks ago when I finally paid off my student loan in Canada and transferred money from Sweden to Canada using a bank in Europe that had better rates than other banks. And the problem in doing that is that you have to file in all these long forms to ensure that you're not performing any kind of money laundering. And these forms are super complex to fill out. Press on the help button, boom, someone appeared, took about a minute, and the sentence I didn't understand was explained, and the case was resolved. Kill the call, go on with your life. And this brings me to a thought I had, is that usually in RTC we've always had call length as a metric. But maybe now we shouldn't be using call length as a metric, because a lot of these experiences will be embedded in bigger experiences, such as the wonderful world of banking, and they might just be small punctual calls where things are resolved in 30 seconds or in 1 minute. And so this traditional way of looking at, the call length should be longer than this, or X, or should be growing, maybe is starting to get irrelevant. And so that's really the story. It's a story about iterating. It's a story about finally now an RTC entrepreneur can get into this game without hitting the massive number of walls that I've hit over the past 15 years. The walls have been removed. Now the only wall is your imagination and how quickly you can innovate. So before I leave the stage, I'd just like to make one last plea. We are a team of less than 40, I would say about 35 engineers, including myself as overhead. We're a small team. We're based out of Stockholm, Kirkland, and Mountain View. And we're dedicated to make WebRTC happen, and we're looking for good engineers. If you're interested in joining Google and helping us make WebRTC an even bigger reality, please contact me at my email address or Twitter handle. I'll be more than happy to speak with you about this. So that's it. Thank you for listening.